Okay, now let's start with the Clausius inequality, and we're going to consider another thermodynamic state function called the Gibbs free energy. And so we start with the Clausius inequality, and we'll bring T to the left side of the equation, and we'll use the first law because we know that du, dq plus dw, du is the change in internal energy that's equal to the heat flow and the work performed. That means dq can be written as du minus dw. So we'll put that in for dq. And then we'll also represent this. We'll represent U through the enthalpy. And so we know that the enthalpy is equal to U plus PV. And so that means du is equal to dH minus dPV. So we'll put that in for du. And then we're going to expand out terms. dW is minus PdV. That'll give us a plus PdV term. And the PdV's cancel, and we get, as a result, dH minus VdP. Now bring everything over to the right side of the equation. So we have 0 is greater than or equal to dH minus TdS minus VdP. And I'm going to write the differential of H minus TS. Now this is introducing a term minus S dt. So I'll have to cancel it. So I've introduced a minus S dt. I'll introduce a plus S dV, so that cancels. And now I'm going to impose constant temperature and pressure. And therefore dt and dp are both 0, so those terms fall out. So I just have the change in the expression H minus Ts has to be less than or equal to 0 for the Clausius inequality to hold. And so that means I can introduce a state function H minus Ts. I'll define that as being G, the Gibbs free energy. And what that tells us is that in order for the Clausius inequality to hold, then the Gibbs free energy change for a process has to be negative, less than 0. It can be 0 if the process is reversible, but it will always be less than 0 for a non-reversible process. So if I can write this as delta G has to be negative for a spontaneous process. What is a spontaneous process? It is a process that occurs in the natural direction of the universe. It doesn't say how fast it's going to occur, but just that it wants to occur. Now let's consider an example. Let's say we have a mountain, and in the mountain we have a lake here in the top. So this is water, and this water is held by two peaks at the mountain. Well, this water wants to run downhill because it's being pulled by gravity. But as long as there's two peaks holding the water in, it will stay there forever, as long as it doesn't all evaporate or sink into the dirt. But say we drill a hole through one of the peaks. If that's the case, then the water will spontaneously go down the mountain because it's being pulled by gravity. So the water going down the mountain is spontaneous. However, there might be some barrier that's keeping it from happening. So delta G being negative means that the reaction or process is spontaneous, but there might be a barrier keeping it from happening. So we have delta G of reaction can be negative, meaning the reaction wants to occur, but there might be a large barrier, an activation barrier, keeping that reaction from occurring at an appreciable rate. Okay, let's consider spontaneous a little bit more. How do we know what's going to happen? How can we tell if something's spontaneous or not? Well, we can calculate delta G. And if delta G is negative, then the reaction or process is spontaneous. But what does that mean? So let's consider everything that happens in the universe happens because a force is acting upon it. Therefore, if we consider all the forces, we have gravity, electromagnetic, and the strong and weak nuclear forces. Those are the four forces in nature. So when something happens, it's because one of these forces is acting upon it. So in our previous example with the water going down the mountain, it goes down the mountain because gravity is applying a force to the water, pulling it toward the surface of the earth. We have electromagnetic forces that, as we saw in the first unit, intermolecular forces. So everything happens in the universe because there are forces acting on things. And that's the direction that processes happen, and that's the spontaneous direction, is because whatever combination of forces there are acting on something is pulling it in that particular direction.